So in order to talk about polarization, we are going to be looking at, okay, I just have to put that on. So we are going to be looking at the lightning and the cloud again, right? So we're going to draw a cloud. Now our cloud experiences what is called polarization, which is the separation of charges. So in our cloud with the lightning, we have at the beginning, we have ice crystals and dust and rain droplets, and they collide. And as they collide, some of the electrons from the ice crystals and the dust actually collect on the rain droplets. Since the electrons are going to go with the rain droplets, it's going to make our rain negatively charged. Again, they just have more electrons than protons. So those are my electrons. So they went with the rain. Well, now we have positively charged particles, because one of the particles had to lose electrons, meaning one now lost electrons and is positively charged, meaning those positively charged particles actually start moving up with the ice crystals. So this is that polarization. One object has more electrons than the other, and those electrons move to one side. Because it does this, it causes a buildup of charge. You have a bunch of electrons all hanging out in one area. And what we know about electrons is they like to repel from each other, right? Likes repel, opposites attract. Well, since they like to repel, they're going to try every method of getting away from each other. And how they're going to find their way of getting away from each other is through lightning. So the electrons repel each other. Because they repel each other, they're going to go down that lightning strike. They're going to find somewhere that is less negatively charged than themselves. So rain is a conductor in the instance that electrons can actually be transferred from one particle to the other. The ground, on the other hand, is what we call an insulator, meaning it doesn't do this as well. Its electrons can't just come off of it. They kind of are trapped on the atom. So when we go to draw our ground, our electrons are trapped, but they're still going to follow the same laws of physics of likes repel. So if there is no atom given to you for ground, you can pick whatever atom you want. But we're going to have our ground atom, our normal one, and we're going to have it have 3 protons. I'm going to put some neutrons in there, and I'm going to have it have 3 electrons. Those electrons are just evenly spaced at this point. They're not being pulled or directed to one side or the other. They're just hanging out like normal. Why? Because there's been no charge interacting with them. So if you don't have a charge interaction, you don't have electric fields, you don't have a force pushing electrons to one side or the other. But when I put a ground atom on the ground, and there's negative charges interacting, meaning that there's the negative charge of lightning coming down, what's going to happen, our protons are still going to be in the center because they're not allowed to move. But our electrons that are hanging out on our atom are going to fall to the other side. They're going to try and get away from that negatively charged lightning. So again, these guys, their electrons cannot come off their atom. These guys could. The difference is this is a conductor, meaning its electrons are allowed to move. These guys are insulators. Their electrons are not allowed to move. They're only allowed to shift in the atom. We call this induced polarization. And the reason we have induced polarization is due to the attraction of the negative charge of the lightning to the positively charged nucleus, as well as the repulsion of the two electrons, the two negative charges. Only other word that I have not mentioned is the electric fields. Electric fields are present anytime you have two or more charges. And remember, this is just related to the fact that there's going to be a force there. Because there's attraction and repulsion, there is an electric field pushing and pulling on these charges in order to get them to follow the rules of likes repel, opposites attract.